What if I told you that right now, as you listen to these words, you might be sitting above the ruins of a civilization that built wonders beyond our wildest dreams, millions of years before we existed? What if human history as we know it is nothing more than humanity's second chance? Don't go anywhere, because tonight we're about to uncover evidence that will change everything you thought you knew about our place on this ancient planet. Hit subscribe, and let's dive into the most mind-bending mystery of our time. What if everything we believe about human civilization is just the final chapter of a much longer story? What if the ruins we marvel at today are merely the most recent remnants of countless rises and falls that stretch back through deep time? If you enjoy exploring these cosmic mysteries with us, gently tap that subscribe button and let's drift together through the unexplored corridors of Earth's hidden past. Picture yourself standing in southeastern Turkey at dawn, as the first rays of sunlight illuminate a collection of massive stone pillars arranged in perfect circles. These aren't just any ancient stones, they're the remains of Göbekli Tepe, and their whispering secrets that have fundamentally changed how we understand our own history. Until recently, archaeologists believed that civilization began around 5,000 years ago with the first cities in Mesopotamia. Agriculture came first, we were told, then settlements, then the complex societies that could organize massive construction projects. It was a neat, logical progression that made perfect sense. Then came Göbekli Tepe. When German archaeologist Klaus Schmidt first encountered this site in the 1990s, he found something that shouldn't exist according to our timeline of human development. Massive limestone pillars, some weighing up to 16 tons, carved with intricate reliefs of animals, foxes, lions, scorpions, vultures, arranged in circular formations that speak of sophisticated planning and profound spiritual significance. The carbon dating results were stunning, 11,500 years old. This meant that hunter-gatherers, people we assumed were struggling for basic survival, had somehow organized the resources and manpower to create one of humanity's first great architectural achievements. They did this before they had pottery, before they had metal tools, before they had discovered agriculture. But here's what makes your mind drift into deeper questions as you imagine walking among these ancient stones. Göbekli Tepe wasn't built gradually over time. Archaeological evidence suggests it was constructed rapidly, as if the knowledge and organizational capacity already existed, fully formed. The precision of the stone cutting, achieved with nothing but flint tools, rivals what we can accomplish today with modern machinery. Even more intriguing, after serving its mysterious purpose for over 1,000 years, Göbekli Tepe was deliberately buried. Not abandoned, buried. Someone carefully filled the entire complex with tons of soil, creating the hill that hid it for millennia. It was as if they wanted to preserve it for a future they knew would come. As you let this image settle in your mind, ancient peoples with seemingly primitive tools creating monuments that challenge our understanding of human capability, consider what else might be hidden beneath our feet. Göbekli Tepe is only 5% excavated. Ground-penetrating radar has revealed at least 20 more circular structures still buried beneath the earth. But Göbekli Tepe is not alone in its impossibility. Across our planet, we find megalithic structures that seem to defy the technological capabilities of their supposed builders. In Peru, the stones of Sacsayhuaman fit together so precisely that you cannot slide a piece of paper between them, despite some weighing over 100 tons. In Lebanon, the Baalbek temple complex contains stone blocks, weighing up to 800 tons, moved and placed with a precision that puzzles modern engineers. On Easter Island, nearly 900 massive stone heads watch over the Pacific, their creation and transportation still not fully understood. At Pumapunku in Bolivia, Andesite blocks are cut with such geometric precision that they appear almost machine-made, yet they date to long before any known civilization possessed such technology. Each of these sites whispers the same question: how? The orthodox archaeological response involves ingenious engineering, massive human labor, and extraordinary determination. Ramps, ropes, levers, and thousands of workers over many decades. While these explanations are certainly possible, they require us to imagine ancient peoples accomplishing feats that would challenge us today, using methods that left no trace in the archaeological record. But what if we're asking the wrong question? What if instead of asking, "How did they do this?" we should be asking, "Who were they, really?" Consider this: our modern industrial civilization will leave traces in the geological record that will be detectable millions of years from now. The concrete in our cities, the steel in our buildings, the plastics in our oceans, the isotopic signatures of our nuclear age, all of these will create a distinct layer that future geologists could identify as the mark of an industrial species. But what if such layers already exist, buried so deep in geological time that we've never thought to look for them? What if the precision and scale of these ancient megalithic sites aren't anomalies in our expected progression from primitive to advanced, but rather the fading echoes of knowledge systems we don't yet understand? As you imagine the morning mist rolling across the ancient pillars of Göbekli Tepe, picture the hands that carved those intricate animal reliefs. Picture the minds that conceived those perfect circles. Picture the society that could organize such an undertaking, then choose to bury it for reasons we can only guess at. The stones are trying to tell us something, but we may not yet know how to listen. They hint at depths of time and cycles of knowledge that stretch far beyond our current historical models. They suggest that the story of intelligence on Earth might be far older, far more complex, and far more mysterious than we've ever dared to imagine. These whispers in stone are just the beginning of our journey together. As we drift deeper into this mystery, we'll explore what science can tell us about detecting ancient civilizations and why the very rocks beneath our feet might hold secrets that could change everything we thought we knew about our place in Earth's long story. But that revelation awaits us just ahead, in the quiet space between sleeping and waking, where impossible questions find their most beautiful answers. The ancient stones have posed their question, and now science offers an unexpected framework for finding answers. In the quiet halls of NASA's Goddard Institute, a climate scientist named Gavin Schmidt was pondering a question that would bridge the gap between rigorous science and the deepest mysteries of our planet's past. Schmidt, along with his colleague Adam Frank from the University of Rochester, wasn't initially trying to prove that ancient civilizations existed. Instead, they were asking a more fundamental question: if an industrial civilization had existed on Earth millions of years ago, would we be able to detect it today? They called their thought experiment the Silurian Hypothesis, playfully named after the intelligent reptilian species from the British science fiction series Doctor Who. Picture Schmidt in his office, surrounded by climate data and geological charts, realizing that this question had never been properly examined by science. We assume we're the first because we see no evidence of previous civilizations, but Schmidt recognized this as potentially circular reasoning. What if we simply didn't know what to look for? The numbers that emerged from their analysis are both humbling and startling. Human industrial civilization has existed for roughly 300 years, the blink of an eye in geological terms. Even if we include the entire span of Homo sapiens, we're talking about 300,000 years. Set against Earth's 4.6 billion-year history, our entire species represents just 0.07% of the planet's existence. But here's where the hypothesis becomes beautifully unsettling. How long would clear evidence of our civilization persist in the geological record? Schmidt and Frank calculated that most traces of our cities, our infrastructure, even our nuclear weapons, would be virtually undetectable after just a few million years. Consider the forces constantly at work reshaping our planet. The ocean floor, where much of our industrial output eventually settles, is completely recycled through plate tectonics every 200 million years. The continents themselves are in constant motion, grinding against each other, folding, fracturing, wearing away. Mountains rise and are worn to dust. Ice ages advance and retreat, scraping the surface clean with mile-thick glaciers. In this context, the preservation of any technological signature becomes remarkably unlikely. If a previous industrial civilization had flourished 100 million years ago, during the Cretaceous period when dinosaurs ruled, would we expect to find their cities today? Their roads? Their monuments? The answer, Schmidt realized, is almost certainly no. But absence of evidence is not evidence of absence, and this is where the Silurian hypothesis becomes truly fascinating. While the physical artifacts of an ancient civilization might vanish, their industrial activities could leave more subtle signatures in the geological record, signatures we might be creating right now without fully realizing it. Imagine an ancient civilization burning fossil fuels just as we do. The carbon isotopes released would create a distinctive pattern in the atmospheric record, preserved in ancient ice cores or ocean sediments. Picture ancient industries processing metals, leaving behind unusual concentrations of rare earth elements in specific geological layers. Envision large-scale agriculture changing the ratios of plant pollens preserved in ancient soils. Most intriguingly, consider nuclear technology. The isotopic signatures of nuclear weapons testing or nuclear power generation could persist in the geological record far longer than any physical structure. These atomic fingerprints might be detectable millions of years after the civilization that created them had vanished completely. Schmidt and Frank didn't stop with theoretical possibilities. They began examining the geological record for precisely these kinds of anomalies, and they found some tantalizing hints. During certain periods in Earth's past, the geological record shows sudden spikes in carbon isotopes, suggesting massive releases of carbon into the atmosphere. The most famous of these events occurred 56 million years ago, during what's called the Paleocene-Eocene thermal maximum, or PETM. Global temperatures rose by 5 to 8 degrees Celsius in just a few thousand years. Geological lightning speed. The orthodox explanation involves massive volcanic activity or the release of methane from ocean sediments. But Schmidt and Frank noted that the carbon isotope signature looks remarkably similar to what we are creating today through industrial fossil fuel burning. Could some of these ancient warming events have been caused by previous technological civilizations? As you drift with this possibility, picture our pale blue dot rotating through the cosmic dark, its surface constantly changing, constantly recycling itself. Imagine previous chapters in the story of intelligence on Earth, their rise and fall lost to the patient geological processes that erase almost everything given enough time. The beauty of the Silurian hypothesis lies not in its certainty, but in its systematic approach to an extraordinary question. Schmidt and Frank created a scientific framework for detecting the undetectable, a methodology for searching Earth's deep memory for whispers of minds that might have contemplated the cosmos long before us. Their work suggests that we should be looking not for ancient cities or monuments, but for subtle chemical signatures, isotopic anomalies, and geochemical fingerprints that might survive the great geological eraser. They've shown us that the question, "Are we alone in time?" is not just philosophical speculation, but a legitimate scientific inquiry with testable predictions. As we continue our gentle journey through these possibilities, we'll explore exactly how Earth erases evidence over deep time, and what traces might manage to survive the planet's relentless recycling. We'll walk through the vast geological processes that both hide and preserve the secrets of our world's mysterious past. The hypothesis has opened a door that can never be closed. The recognition that our planet's history might contain chapters we never imagined, written in languages we're only just beginning to learn to read. To understand why we might never find direct evidence of ancient civilizations, we need to witness Earth's most powerful force, time itself, working through geological processes that dwarf human imagination. Picture our planet as a vast, patient artist, constantly erasing its canvas to create new masterpieces, recycling every mountain, every ocean floor, every trace of what came before. Let's begin beneath the waves, in the abyssal depths, where most of our modern civilization's remnants will eventually settle. The ocean floor seems permanent from our brief human perspective, but it's actually the most temporary surface on Earth. Through the relentless process of seafloor spreading, new oceanic crust forms at mid-ocean ridges, pushes outward for millions of years, then gets swallowed back into the Earth's interior at subduction zones. Imagine standing at the mid-Atlantic ridge, watching molten rock emerge from Earth's interior to create new seafloor. This newborn crust will slowly spread outward at about the same rate your fingernails grow. It sounds impossibly slow, but over geological time, this gentle movement completely recycles the entire ocean floor every 200 million years. Every piece of plastic ever made, every sunken ship, every trace of our industrial output that settles to the ocean bottom, all of it will eventually be dragged into subduction zones and melted back into the planet's interior. The evidence dissolves into magma, becoming raw material for future volcanic eruptions that will know nothing of the civilization that created the original debris. But the ocean's recycling program is just one of Earth's erasure mechanisms. On land, the process is more subtle, but equally thorough. Picture water, that most gentle and persistent force, working grain by grain to level every mountain range that ever rose. The Himalayas, Earth's tallest peaks, lose several millimeters of height each year to erosion. Not much by human standards, but enough to reduce them to rolling hills in just a few dozen million years. Rivers are Earth's moving highways, constantly transporting the remnants of continents grain by grain toward the sea. The Mississippi River alone carries 550 million tons of sediment to the Gulf of Mexico each year. Every ancient city that ever stood along its banks, every trace of human habitation gets mixed into this vast conveyor belt of sediment and dispersed across the ocean floor. Consider the Colorado River, which carved the Grand Canyon in just 6 million years. As you imagine standing on the canyon's rim, looking down through those layers of exposed geological history, realize that this represents just the preservation of sediments. The vast majority of rock layers that once existed above have been completely erased, carried away grain by grain to distant seas. Now picture the most dramatic erasure mechanism of all: ice ages. Every 100,000 years or so, mile-thick glaciers advance from the polar regions, scraping entire continents clean like cosmic bulldozers. These ice sheets, sometimes reaching 2 miles in height, can carve new valleys, relocate mountains, and completely resurface vast areas of land. During the last ice age, which ended just 12,000 years ago, glaciers covered most of Canada and extended deep into what is now the northern United States. These ice sheets scraped away everything: soil, vegetation, even solid bedrock, carrying it all southward and depositing it in new locations. Entire mountain ranges were ground down and scattered as till across the landscape. If any civilization had existed in these glaciated regions before the ice advanced, virtually every trace would have been obliterated. The ice doesn't preserve, it destroys, mixing, grinding, and relocating everything in its path before melting away and leaving behind a completely reorganized landscape. But even in regions that escape direct glaciation, the effects of ice ages are profound. Sea levels drop by 400 feet when water becomes locked in continental ice sheets, exposing vast areas of ocean floor that later become submerged again when the ice melts. Any coastal civilizations, and most advanced civilizations tend to be coastal, would be alternately exposed and drowned by these cycles. Consider how many of our own cities lie within 400 feet of current sea level. New York, London, Tokyo, Los Angeles, all would be completely underwater if sea levels rose by the amount they varied during past ice ages. An ancient civilization's greatest cities, their ports and centers of learning, would most likely now lie beneath hundreds of feet of ocean water, slowly being buried under accumulating sediments. The forces working to erase evidence operate on multiple timescales. Chemical weathering breaks down even the most durable materials. The limestone blocks of Egyptian pyramids, built just 4,500 years ago, are already showing significant erosion from acid rain and chemical weathering. Metal objects corrode and return to oxide form. Even concrete, which we consider so permanent, has an estimated lifespan of just 50–100 years under normal conditions. DNA, that most fundamental signature of life, degrades completely in most environments within 1,000,000 years at most. Organic materials like wood, paper, or fabric decompose in decades or centuries. Even plastic, for all its environmental persistence, begins to break down into microparticles that become indistinguishable from natural sediments over geological time. Perhaps most humbling of all is plate tectonics itself, the slow dance of continents across Earth's surface. The positions of our continents today bear no resemblance to their arrangement 200 million years ago. Mountains have been raised and destroyed. Oceans have opened and closed. Entire continents have collided and been torn apart. Any landmass that hosted an ancient civilization might now be at the bottom of an ocean, or buried beneath miles of sediment, or scattered across multiple continents, or completely recycled into new rock formations. The very ground beneath an ancient city might now be part of a mountain range on the opposite side of the planet. As you let these vast processes wash over your imagination like slow-motion tsunamis of change, realize that we're witnessing Earth's most fundamental characteristic: impermanence. Everything that seems solid and eternal from our perspective, the mountains, the continents, the ocean floors, is actually in constant motion, constantly being recycled, constantly being renewed. This is the context in which we must search for evidence of ancient civilizations. We're not looking for intact artifacts or pristine ruins. We're looking for whispers and shadows, for subtle chemical signatures that somehow manage to slip through Earth's vast recycling system without being completely erased. The question becomes not, why don't we see obvious evidence, but rather, what subtle traces might have survived against all odds? And, as we'll discover next, there are indeed ways that ancient industrial activity might leave fingerprints in the geological record. Signatures so fundamental that even Earth's Great Eraser cannot completely remove them. While Earth's Great Eraser works tirelessly to remove the obvious traces of civilization, certain signatures can slip through the net of geological recycling. These are the subtle chemical whispers that speak not in the language of monuments and artifacts, but in the atomic grammar of isotopes and elements, preserved in layers of sediment that accumulate grain by grain across the millennia. Picture a lake, perfectly still in the early morning light, its surface like glass reflecting the sky. Each year, sediments settle to the bottom in distinct layers: pollen from surrounding forests, dust from distant winds, organic matter from the lake's own ecosystem. Over thousands of years, these layers build up like pages in a book, each one recording the environmental conditions of its time. Now imagine an ancient industrial civilization existing near this lake 50 million years ago. While their cities would long since have crumbled to dust, their industrial activities might have left chemical signatures in those sediment layers, signatures that could survive even as the lake dried up, was buried, and turned to rock. The most telltale signature would be in carbon isotopes. When we burn fossil fuels today, we release carbon that has been locked away underground for millions of years. This ancient carbon has a distinctive isotopic signature. It's enriched in carbon-12 compared to carbon-13, creating a pattern that atmospheric scientists can detect in ice cores and ocean sediments. An ancient civilization burning their own fossil fuels would create the same isotopic anomaly. 50 million years from now, future scientists might find a thin layer in rock formations showing this same carbon-12 spike, lasting perhaps a few thousand years before returning to normal levels. To them, it might look exactly like the signature we're creating today. But carbon isn't the only potential fingerprint. Picture ancient smelting operations, processing metals from ore just as we do today. Different metals require different temperatures and processes, often involving chemicals that don't occur naturally in such concentrations. A civilization mining and processing copper might leave elevated levels of copper and associated elements in nearby sediments. Ancient steel production could leave iron and carbon signatures, along with traces of the coal or charcoal used in the process. Even more intriguing are the rare earth elements, materials crucial for advanced technology, but normally dispersed in tiny concentrations throughout the crust. Our modern electronics industry concentrates these elements in unprecedented amounts. Neodymium for magnets, lithium for batteries, platinum for catalysts. An advanced civilization would almost certainly need to extract and concentrate these same materials, potentially leaving spikes of these elements in the geological record. Consider what we're creating right now that future geologists might recognize. Our concrete production releases distinctive isotopic signatures of calcium and silicon. Our fertilizer industry has doubled the amount of nitrogen in the global ecosystem, changing the nitrogen isotope ratios in sediments worldwide. Our nuclear industry has scattered artificial isotopes, cesium-137, strontium-90, plutonium-239, that will be detectable for thousands of years. Perhaps most permanent of all are the changes we're making to the global climate system. The carbon dioxide we've added to the atmosphere is causing ocean acidification, which leaves its own chemical signature in the shells of marine organisms. These shells settle to the ocean floor and can be preserved in limestone formations for hundreds of millions of years. An ancient civilization facing their own climate crisis might have left similar signatures. Picture their equivalent of our Industrial Revolution, burning vast quantities of organic carbon and releasing it into the atmosphere. The resulting warming might have triggered the release of additional carbon from natural sources, methane from warming soils, carbon dioxide from warming oceans, creating a cascade effect preserved in the chemical composition of ancient sediments. Interestingly, Earth's geological record does contain several rapid warming events that bear some resemblance to what we're experiencing today. The Paleocene-Eocene thermal maximum, 56 million years ago, shows exactly this kind of carbon isotope signature. Global temperatures rose by 5 to 8 degrees Celsius over just a few thousand years, accompanied by the isotopic signature of massive carbon release. The mainstream explanation involves natural causes, volcanic activity, or the destabilization of methane deposits, but the speed and scale of the warming are remarkably similar to current human-caused climate change. Could some of these ancient warming events have been anthropogenic, caused by previous civilizations burning through their own fossil fuel reserves? There's another class of signatures that would be even more definitive: nuclear isotopes. The atoms created by nuclear fission or fusion don't occur naturally on Earth in significant quantities. Elements like technetium-99 or unusual isotope ratios of uranium and plutonium would be smoking guns for technological activity. Our own nuclear age began in 1945, and we've already scattered enough artificial isotopes around the planet to create a permanent signature in the geological record. Future scientists will be able to identify the exact decade when humans split the atom, recorded in the fallout patterns preserved in ice cores, sediments, and coral reefs. An ancient nuclear age would leave similar traces, though finding them would require knowing where to look and what to look for. Nuclear waste has a half-life of thousands to millions of years, long enough to potentially survive several geological cycles if it ended up in the right depositional environment. But here's what makes the search particularly challenging. These chemical signatures would be subtle, lasting perhaps a few thousand to a few million years in the geological record. In the context of Earth's 4.6 billion-year history, they would appear as brief blips, easily missed unless you were specifically looking for them in the right rock layers. Moreover, the preservation of these signatures depends heavily on local conditions. Sediments deposited in deep ocean basins have the best chance of preservation, but even these eventually get subducted and recycled. Lake sediments can be preserved if they're buried quickly and avoid erosion. Ice cores preserve atmospheric chemistry, but only for the last few million years at most. The search for ancient industrial signatures requires a different kind of archaeology, one that reads chemistry rather than artifacts, one that looks for atomic fingerprints rather than physical structures. It's detective work at the molecular level, searching through millions of years of sedimentary evidence for brief moments when the chemical composition of Earth's surface was altered by intelligence. As we drift deeper into this possibility, imagine geochemists of the future analyzing rock cores from our own era. They would see the plastic particles, the altered nitrogen ratios, the carbon isotope spike, the scattered plutonium, an unmistakable signature of a technological species that briefly altered the chemistry of an entire planet. The question that haunts this search is simple. If we can leave such clear signatures in the geological record, who else might have done the same? And if they did, their traces might be hiding in plain sight, waiting in ancient rock formations for scientists who know what questions to ask. But perhaps the most intriguing evidence might not be hidden in remote geological formations at all. Perhaps it lies beneath the waves that cover most of our planet's surface, in the drowned landscapes of our continental shelves, where entire civilizations could be resting beneath hundreds of feet of water and sediment. In the mountains of South Africa, scattered across an area larger than Los Angeles, lies one of archaeology's most controversial discoveries. Here among the rolling hills near the town of Badplas stand the remnants of what appears to be a vast ancient settlement. Thousands upon thousands of circular stone structures connected by an intricate network of channels and roads spreading across the landscape as far as the eye can see. Picture yourself flying over this region in the golden light of an African sunset, watching the shadows reveal the geometric patterns below. From the air, the structures are unmistakable. Perfect circles, uniform in design, arranged in clusters that suggest neighborhoods, districts, even suburbs. Ground-penetrating radar has revealed that many more lie buried beneath centuries of soil and vegetation, suggesting this complex could contain over 200,000 structures. The man who brought this discovery to global attention is Michael Tellinger, a South African researcher whose claims about the site have sparked fierce debate in archaeological circles. According to Tellinger, these ruins represent the remnants of a sophisticated civilization that flourished in southern Africa far earlier than mainstream archaeology accepts, possibly 200,000 years ago or more. If these dating estimates are correct, they would fundamentally challenge our understanding of human development. 200,000 years ago places us at the very dawn of anatomically modern humans, long before the development of agriculture, metalworking, or complex societies as we understand them. The circular structures themselves are puzzling. Built from local dolerite stone, they range from 30 to 150 feet in diameter, with walls that show evidence of sophisticated construction techniques. Many have no obvious entrances, while others are connected by stone channels that seem designed to direct water flow. The precision of the construction, with stones fitted together without mortar, echoes the megalithic techniques we've seen at sites like Göbekli Tepe. What makes these structures particularly intriguing is their apparent connection to ancient gold mining operations. South Africa has always been rich in gold, and the region around these ruins contains some of the world's oldest gold mines. Tellinger suggests the circular structures were built by people who were systematically extracting gold from the earth on an industrial scale, far earlier than any known civilization. The presence of ancient mining activity in the region is not disputed. Archaeological evidence clearly shows that people were mining and working gold in southern Africa at least 100,000 years ago. Far earlier than gold, working appeared anywhere else in the world. What remains controversial is the scale and sophistication that Tellinger attributes to these operations. According to his interpretation, the circular structures served as energy devices, somehow connected to the mining operations through acoustic properties and electromagnetic effects. He points to the unusual electromagnetic readings in the area, the acoustic properties of the stone circles, and their alignment with celestial bodies as evidence of advanced technological understanding. Mainstream archaeology views these claims with considerable skepticism. The dating methods Tellinger uses are controversial, and many archaeologists argue that the structures could be much more recent, perhaps just a few hundred to a few thousand years old. Natural weathering and soil accumulation can make relatively recent structures appear much older than they actually are. The lack of organic material suitable for carbon dating makes precise age determination difficult. Without pottery shards, tools, or other clearly associated artifacts, it's challenging to establish when the structures were built or by whom. Some researchers suggest they might be the remains of African settlements from the past millennium, made to appear ancient by the harsh weathering conditions of the High Veld. Yet as you imagine walking among these ruins in the cool mountain air, feeling the precisely fitted stones beneath your feet, certain questions linger. The sheer scale of the complex is undeniable. This is not a small village or temporary settlement, but what appears to be a large urban area. The uniformity of construction across such a vast area suggests centralized planning and organization. Moreover, the sophisticated understanding of water management displayed in the channel systems speaks to advanced engineering knowledge. These channels direct rainwater through the complex in intricate patterns, suggesting the builders had a deep understanding of hydrology and landscape management. The connection to gold mining adds another layer of mystery. Gold has no practical value for basic survival. It's soft, difficult to work with primitive tools, and has no use in making weapons or everyday implements. Yet something motivated ancient peoples to invest enormous effort in extracting it from the earth. Why would people with supposedly primitive technology devote such resources to mining a metal with no practical applications? Some researchers have suggested that ancient peoples may have discovered gold's unique electrical properties long before modern science. Gold is an excellent conductor, doesn't corrode, and has unusual electromagnetic characteristics. Could ancient peoples have developed technological applications for gold that we don't fully understand? The broader implications of these South African ruins extend beyond any single site. They represent a pattern we see repeated across Africa, evidence of sophisticated ancient activities that don't fit neatly into our accepted timelines of human development. Great Zimbabwe, the massive stone city that gave the country its name, demonstrates that advanced African civilizations were building impressive structures long before European contact. In the Sahara, before it became a desert, ancient peoples created sophisticated rock art depicting advanced astronomical knowledge and what appear to be technological devices. The Dogon people of Mali possessed detailed knowledge of stellar astronomy, including facts about the star Sirius that weren't verified by modern science until the 20th century. As you consider these scattered pieces of evidence across the African continent, a different picture of ancient human capability begins to emerge. Rather than a simple linear progression from primitive to advanced, we might be looking at cycles of development, civilizations that rose, flourished, and fell long before the historical periods we're familiar with. Africa, as the cradle of human evolution, would have been home to our species longer than any other continent. If complex civilizations could arise and vanish over hundreds of thousands of years, Africa would be the most likely place to find their traces. The challenge lies in separating legitimate archaeological mystery from speculative interpretation. The ruins in South Africa are real. Their age, purpose, and builders remain genuinely uncertain. Whether they represent evidence of sophisticated ancient technology or simply unusual but conventional archaeological sites continues to generate debate. What's not debatable is the broader principle they illustrate. Our planet contains archaeological puzzles that do not fit easily into accepted historical frameworks. These anomalies might represent gaps in our knowledge, errors in our dating methods, or evidence of human capabilities that existed far earlier than we've previously recognized. As we drift toward the horizon of these possibilities, consider how much of Earth's surface remains unexplored archaeologically. Vast areas of Africa, covered by jungle, desert, or simply remote from academic attention, could contain similar surprises. More intriguingly, vast areas of our planet lie beneath the ocean, where sea level changes have hidden and preserved landscapes that were once dry land. The mystery of the African metropolis reminds us that every generation of archaeologists has had to revise their understanding of the past based on new discoveries. The question isn't whether we'll find more evidence of unexpectedly ancient human achievements. It's where we'll find it, and how dramatically it might change our understanding of our own deep history. Imagine standing on the edge of a continental shelf, looking out across what appears to be empty ocean. Beneath these waves extending for dozens of miles toward the deep ocean floor lies a hidden landscape that was once dry land, a vast plain where rivers flowed, forests grew, and perhaps entire civilizations flourished, before being swallowed by rising seas. During the last ice age, just 20,000 years ago, sea levels were 400 feet lower than they are today. This means that millions of square miles of what is now ocean floor was once exposed, habitable land. Picture the eastern seaboard of the United States extending 100 miles further into the Atlantic. Imagine Britain connected to continental Europe by a vast plain called Doggerland. Envision Southeast Asia as a continuous landmass connecting what are now islands scattered across thousands. Picture Earth as a vast library, its shelves filled with the accumulated knowledge and achievements of countless civilizations. Now imagine cosmic forces that can, in an instant, burn that library to the ground, scattering its contents to the winds and leaving only the most resilient fragments for future archaeologists to puzzle over. Our planet exists in a dangerous cosmic neighborhood, subject to catastrophic events that can reset the trajectory of life and civilization with devastating suddenness. The most dramatic reset button lies in space itself. Asteroid impacts that have shaped Earth's history, with violent punctuation marks of destruction and renewal. 66 million years ago, a 6-mile-wide asteroid slammed into the Yucatan Peninsula with the force of billions of nuclear weapons, ending the age of dinosaurs and clearing the stage for mammalian evolution. This wasn't a gradual decline. It was a sudden, catastrophic restructuring of life on Earth. But Earth's geological record reveals that large impacts are not rare events on cosmic timescales. Every few million years, objects large enough to cause regional or global catastrophes strike our planet. The Tunguska event of 1908, which flattened 2,000 square kilometers of Siberian forest, was caused by an object only 100 feet across. Imagine what a mile-wide asteroid could do to modern civilization. And then consider that such impacts occur roughly every million years. For any ancient civilization, even one with technology matching our own, a large asteroid impact would be an existential threat. The immediate blast would devastate continents, but the global effects would be even more catastrophic. The impact would throw billions of tons of debris into the atmosphere, blocking sunlight for months or years. Global temperatures would plummet, crops would fail worldwide, and the intricate networks that support complex civilization would collapse. Even if some populations survived in isolated refuges, the knowledge base of their civilization, their libraries, their educational institutions, their technological infrastructure, would be largely destroyed. The survivors would be thrown back to subsistence living, struggling to maintain even basic crafts and technologies. Within a few generations, much of their ancestors' sophisticated knowledge would be lost, surviving only as fragmented myths and legends. But asteroids are not the only cosmic reset mechanism. Our Sun, that seemingly stable source of life and energy, is actually a variable star prone to periods of intense activity. Solar flares and coronal mass ejections can unleash electromagnetic pulses that disrupt electronic systems across entire hemispheres. The Carrington event of 1859, the largest recorded geomagnetic storm, caused telegraph systems worldwide to fail and produced auroras visible as far south as the Caribbean. A similar event today would cripple our electronic civilization, destroying satellites, power grids, and the digital infrastructure that modern society depends upon. But ancient civilizations might have been vulnerable to different kinds of solar disruption. If they had developed technologies we do not understand, perhaps based on electromagnetic or acoustic principles, intense solar activity could have rendered their entire technological base obsolete overnight. Even more devastating are the supervolcanic eruptions that occur when massive magma chambers beneath Earth's surface finally release their pressure. The Toba supervolcano eruption 74,000 years ago came close to driving our own species to extinction, reducing the global human population to perhaps as few as 10,000 individuals. The ash and sulfur dioxide released into the atmosphere caused a volcanic winter that lasted for years, with global temperatures dropping by up to 10 degrees Celsius. Yellowstone, one of the world's most famous supervolcanoes, has erupted 3 times in the past 2.1 million years, each time releasing more than 1,000 cubic kilometers of material into the atmosphere. When it erupts again, and geological evidence suggests it will, the immediate devastation would cover most of North America in ash, while the climate effects would be felt globally for decades. Picture an ancient civilization at its height, perhaps having developed technologies and knowledge systems that rival or exceed our own, suddenly faced with such a catastrophe. Their cities would be buried under meters of ash. Their agricultural systems would collapse as crops failed in the perpetual twilight, and their population would crash as complex social systems broke down under the strain of survival. The geological record preserves evidence of even more exotic, catastrophic events. Around 12,900 years ago, at the end of the last ice age, something caused rapid climate change that plunged the northern hemisphere back into glacial conditions for over 1,000 years. This event, called the Younger Dryas, coincided with the extinction of many large mammal species and significant changes in human settlement patterns. Some researchers propose that this event was triggered by the impact of a fragmented comet, creating multiple explosions across North America. The evidence includes a layer of sediment containing microscopic diamonds, metallic spherules, and other materials consistent with extraterrestrial impact. If confirmed, this would represent a cosmic catastrophe that struck just as human civilization was beginning to develop agriculture and permanent settlements. The timing is particularly intriguing because it coincides with the end of what archaeologists call the Paleolithic period and the beginning of the Neolithic, the transition from hunter-gatherer societies to agricultural civilizations. Could this transition have been forced upon human societies by a cosmic catastrophe that destroyed whatever more advanced civilizations might have existed during the Ice Age? Consider also the role of Earth's magnetic field, which protects us from deadly cosmic radiation. The magnetic field has reversed many times throughout geological history, and during these reversals, the protective magnetic shield weakens dramatically. Some researchers suggest that during these periods of magnetic vulnerability, increased cosmic radiation could cause mass extinctions, climate changes, and the breakdown of complex ecosystems. An advanced civilization existing during a magnetic reversal might face challenges we can barely imagine. Increased radiation could disrupt their technologies, cause widespread health problems, and make large areas of the planet uninhabitable. The breakdown of the magnetic field might also affect any technologies that depend on electromagnetic phenomena in ways we do not fully understand. Perhaps most sobering is the realization that these catastrophic events operate on timescales much longer than human civilization, but much shorter than geological time. A major asteroid impact every million years, a supervolcanic eruption every few 100,000 years, magnetic reversals every several 100,000 years. These are not abstract possibilities, but certainties, woven into the very fabric of Earth's dynamic systems. For any civilization developing over tens or hundreds of thousands of years, encountering one or more of these reset events would be almost inevitable. The question becomes not whether ancient civilizations faced such catastrophes, but how they might have prepared for them, survived them, or been destroyed by them. Some researchers speculate that certain ancient monuments, the Great Pyramid of Giza, Stonehenge, or the massive stone heads of Easter Island, might represent attempts by ancient peoples to create permanent markers that could survive catastrophic events. Built from the most durable materials available, positioned to encode astronomical and mathematical knowledge, these monuments might be messages from civilizations that knew their time was limited. As you drift with this possibility, imagine looking up at the night sky from the perspective of an ancient astronomer, perhaps 50,000 years ago, watching for signs of approaching danger in the cosmic dance of planets and asteroids. Picture their civilization as efforts to preserve their most important knowledge in forms that could survive whatever catastrophes the universe might send their way. The cosmic reset button reminds us that intelligence on Earth exists in a precarious balance, with forces far beyond any civilization's control. No matter how advanced, no matter how prepared, any terrestrial civilization remains vulnerable to the vast, indifferent forces that shape our planet's destiny. But perhaps the most remarkable aspect of these cosmic catastrophes is not their power to destroy, but the resilience of life itself to recover and rebuild. After each mass extinction, after each global catastrophe, life has found new ways to flourish, often becoming more complex and sophisticated than before. The question that haunts our exploration is whether intelligence, too, might be part of this cycle, rising, falling, and rising again in patterns too vast for any single civilization to perceive. To understand what traces of ancient civilizations we might hope to find, we must first understand what ghosts our own civilization will leave behind. Picture Earth, 100 million years from now, when our species has long since vanished and geological forces have worked their patient magic on our cities, our technologies, and our dreams. What evidence would remain that we were here? What signatures would survive to puzzle future geologists who might wonder if intelligence once flourished on this blue world? The answer is both humbling and profound. While our greatest monuments will crumble to dust, while our cities will be recycled by geological processes, the chemical fingerprints of our industrial age will persist in Earth's memory far longer than our physical artifacts. We are writing our signature not in stone and steel, but in the very atoms of our planet's atmosphere, oceans, and sediments. Begin with the most obvious marker: plastic. In just 70 years, we have produced over 9 billion tons of plastic, much of which will persist in recognizable form for thousands of years. But even more permanent is the molecular breakdown of plastic into microparticles that become incorporated into sediments worldwide. These synthetic polymer fragments have a chemical signature unlike anything produced by natural biological processes, creating a distinctive marker layer that could be detectable millions of years from now. Picture future geologists examining sediment cores and finding a thin layer, perhaps just a few millimeters thick, that contains unprecedented concentrations of complex synthetic molecules. This plastic horizon would mark the brief moment in Earth's history when a species learned to create entirely new materials from petroleum, then scattered these artificial substances across every ecosystem on the planet. But our chemical signatures go far deeper than plastic waste. The concrete in our buildings, roads, and infrastructure represents one of the largest geochemical transformations in Earth's recent history. We produce over 4 billion tons of concrete annually, fundamentally altering the natural ratios of calcium, silicon, and aluminum compounds in near-surface environments. The distinctive isotopic signature of industrial cement production will be preserved in geological formations long after our concrete structures have weathered away. Our metal industries have created even more dramatic chemical anomalies. We extract and concentrate metals from ore deposits, then scatter them in new forms across the planet's surface. The aluminum in our buildings and vehicles doesn't occur naturally in metallic form on Earth's surface. It requires enormous energy input to separate it from aluminum oxide. Future investigators would find unusual concentrations of pure aluminum, often alloyed with other metals in combinations that don't occur naturally. Similarly, our electronics industry has created unprecedented concentrations of rare earth elements. Neodymium, used in virtually every modern electronic device, is normally scattered in trace amounts throughout Earth's crust. Our technology has concentrated this element in quantities that would create distinctive spikes in the geological record, particularly in areas where electronic waste has accumulated. Perhaps most permanent of all is our nuclear signature. Since 1945, we have conducted over 2,000 nuclear weapons tests, scattering artificial isotopes across the entire planet. Cesium-137, strontium-90, and plutonium-239 don't occur naturally in significant quantities on Earth. These isotopes have half-lives of thousands to millions of years, meaning they will remain detectable in ice cores, sediments, and coral reefs far into the geological future. The accident at Chernobyl in 1986 created a particularly concentrated deposit of artificial isotopes that will remain identifiable for millennia. Future scientists examining sediment layers from that period would find a clear spike in radioactive isotopes concentrated in a pattern that spreads northwest from a specific location in Ukraine, a signature as distinctive as a fossil but written in the language of atomic decay. Our alteration of Earth's atmosphere may be the most profound signature of all. We have increased atmospheric carbon dioxide concentrations by over 40% in just 150 years, creating an isotopic signature that will be preserved in ice cores, ocean sediments, and the shells of marine organisms. This carbon spike has a distinctive isotopic ratio that identifies its source as fossil fuel burning, ancient organic carbon that was locked away underground for millions of years, now released back into the active carbon cycle. The climate changes driven by this carbon release are creating their own permanent markers. Ocean acidification is altering the chemistry of seawater, affecting the shell formation of countless marine species. These chemical changes will be preserved in limestone deposits forming today, creating a geological record of rapid atmospheric change that could be detected millions of years in the future. Our industrial nitrogen fixation for fertilizer production has doubled the amount of reactive nitrogen in Earth's biosphere, permanently altering the nitrogen isotope ratios in soils and sediments worldwide. This nitrogen signature is being incorporated into the tissues of plants and animals across the globe, creating a marker of intensive agriculture that will persist in the geological record. Even our space activities are leaving traces. The thousands of satellites and millions of pieces of space debris in orbit around Earth represent the first time in our planet's history that a species has created a technological layer in space. While most of this material will eventually decay and fall back to Earth, the isotopic signatures of rocket fuel combustion and satellite materials are being deposited in Earth's upper atmosphere in patterns that do not occur naturally. But perhaps the most intriguing aspect of our industrial ghosts is how they might be misinterpreted by future scientists. Imagine researchers millions of years from now discovering the plastic horizon, the nuclear isotope spikes, the carbon signature of fossil fuel burning, and the metal concentration anomalies. Would they recognize these as signatures of intelligence, or would they develop alternative explanations? The carbon isotope spike might be attributed to massive volcanic activity or methane releases from warming soils. The metal concentrations could be explained by unusual meteorite impacts or previously unknown geological processes. The plastic particles might be seen as evidence of some exotic biological process that briefly evolved the ability to create synthetic polymers. This interpretive challenge works both ways. If we found similar chemical signatures in ancient geological formations, would we recognize them as evidence of previous industrial civilizations? The very markers that seem so obvious to us, because we know we created them, might be much more ambiguous when preserved in ancient rocks, and viewed from the perspective of scientists who assume they're looking at natural phenomena. Consider what we might have missed in our examination of Earth's geological record. We found organic carbon spikes in ancient sediments and attributed them to volcanic activity or methane releases. We've discovered unusual metal concentrations in certain rock layers and explained them as the result of asteroid impacts or hydrothermal activity. We've identified rapid climate changes in the geological past and assumed they were caused by natural variations in Earth's systems. Any of these phenomena could potentially be reinterpreted as the signatures of previous industrial civilizations if we knew what to look for and were willing to consider the possibility. The challenge lies in distinguishing between natural processes and the remnants of intelligence, especially when that intelligence might have operated according to principles we don't understand. Our own industrial ghosts reveal both the permanence and the subtlety of technological signatures in the geological record. While our physical artifacts will largely disappear, our chemical fingerprints will persist as whispers in stone, readable by anyone who understands the language of isotopes and elements. As we prepare to expand our search beyond Earth itself, consider that our industrial age represents just one possible pathway for technological development. Other civilizations might have left entirely different signatures based on different technologies, different materials, different relationships with their planetary environment, but the principles remain the same. Any sufficiently advanced civilization must extract resources, concentrate materials, and alter the chemistry of its environment. These alterations leave traces that can survive long after the civilization itself has vanished, creating industrial ghosts that haunt the geological record with their atomic memories. As our exploration of ancient civilizations on Earth reaches toward its conclusion, we must lift our gaze beyond our blue world to consider a possibility, both thrilling and unsettling. What if the evidence we seek isn't hidden in Earth's geological layers at all, but scattered across the other worlds of our solar system, waiting in the airless silence of space? Picture our moon, hanging in the velvet darkness above you, its ancient surface scarred by billions of years of asteroid impacts. Unlike Earth, the moon has no atmosphere to weather away artifacts, no plate tectonics to recycle its crust, no erosion to erase the traces of the past. On the lunar surface, footprints can last for millions of years. If ancient civilizations from Earth ever developed space travel, or if visitors from other worlds once explored our solar system, the moon might preserve their traces like a vast archaeological museum suspended in the cosmic dark. This isn't mere science fiction speculation. Serious scientists have proposed that we should examine the lunar surface for signs of ancient artifacts or structures that couldn't have formed naturally. The Apollo astronauts photographed thousands of lunar features, but they were looking for geological formations, not archaeological sites. A systematic archaeological survey of the moon, using high-resolution satellite imagery and eventually robotic exploration, might reveal structures or objects that have been hiding in plain sight. Consider what such artifacts might look like after millions of years in the lunar environment. Metal objects would remain largely intact in the vacuum of space, though they might be partially buried under layers of dust accumulated from micrometeorite impacts. Geometric structures would stand out clearly against the natural chaos of impact craters and mountain ranges. Even the remnants of ancient mining operations might still be visible, appearing as unnaturally regular excavations or the geometric patterns of systematic resource extraction. The moon's far side, permanently hidden from Earth's view, offers an even more intriguing archaeological frontier. This hemisphere is heavily cratered and geologically ancient, providing stable surfaces where artifacts could remain undisturbed for geological ages. If ancient visitors wanted to establish a permanent base in our solar system, the far side of the moon would offer ideal conditions: protection from Earth's radio noise, constant visibility of deep space for navigation, and geological stability. But our exploration needn't stop at the moon. Mars, with its thin atmosphere and slow geological processes, could also preserve evidence of ancient visitors or indigenous civilizations for millions of years. The red planet's surface shows clear evidence of past flowing water, dense atmospheres, and potentially habitable conditions. If life once flourished on Mars, it might have developed intelligence long before similar processes began on Earth. Recent discoveries have revealed that Mars was much more Earth-like in its distant past than previously thought. 4 billion years ago, Mars had a substantial atmosphere, liquid water oceans, and a magnetic field to protect against cosmic radiation. These conditions persisted for hundreds of millions of years, more than enough time for complex life to evolve and potentially develop intelligence. The remnants of such a Martian civilization might still be scattered across the planet's surface, preserved in the dry, cold environment that followed the loss of Mars' atmosphere. Ancient Martian cities might appear today as geometric patterns of erosion-resistant materials, their original architecture long since buried under dust, but still detectable through careful analysis of surface features. Even more intriguingly, if ancient Martians faced the gradual loss of their atmosphere and the cooling of their world, they might have attempted to preserve their civilization through massive engineering projects. The geometric precision of certain Martian features, the almost too-perfect hexagonal crater formations, the linear features that crisscross certain regions, might represent the remnants of planetary-scale efforts to maintain habitability on a dying world. Venus presents perhaps the most mysterious case of all. Hidden beneath its crushing atmosphere and sulfuric acid clouds, Venus might once have been the most habitable planet in our solar system. Recent climate models suggest that Venus could have maintained liquid water oceans for over 2 billion years, during Earth's early history when our own planet was still largely uninhabitable. If Venus once supported life and intelligence, all evidence now lies buried beneath miles of dense atmosphere and surface temperatures hot enough to melt lead. But some researchers speculate that evidence of ancient Venusian civilizations might still exist in the planet's upper atmosphere, where conditions are much more Earth-like. Floating cities or orbital habitats built by ancient Venusians to escape their world's catastrophic greenhouse effect might still be detectable as artificial objects drifting in Venus's clouds. The outer solar system offers even more exotic possibilities. The moons of Jupiter and Saturn, particularly Europa, Enceladus, and Titan, show evidence of subsurface oceans that might have existed for billions of years. These hidden seas, warmed by tidal heating from their giant parent planets, could have provided stable environments for the evolution of intelligent life completely independent of conditions on Earth. Titan, Saturn's largest moon, is particularly intriguing because its thick atmosphere and surface lakes of liquid methane create a completely alien but potentially habitable environment. Life on Titan would be based on entirely different chemistry than Earth life, perhaps using liquid methane instead of water as a solvent. Such exotic life might have developed technologies and left signatures that we wouldn't recognize as artificial because they operate on completely different principles than our own technology. But perhaps the most profound implication of expanding our search beyond Earth is what it suggests about the nature of intelligence itself. If civilizations have arisen independently on multiple worlds within our own solar system, it would mean that intelligence is not a rare accident but a natural outcome of planetary evolution, given suitable conditions and sufficient time. This possibility transforms our entire perspective on the cosmic significance of consciousness. Rather than seeing Earth as a unique oasis of intelligence in a vast dead universe, we might discover that our solar system has been home to multiple flowering of consciousness across billions of years. A cosmic garden where intelligence has bloomed again and again, in different forms, on different worlds, under different stars. The search for ancient artifacts in our solar system would also provide a new framework for understanding the famous Fermi paradox, the puzzling absence of obvious signs of extraterrestrial intelligence despite the vast number of potentially habitable worlds in our galaxy. If intelligence tends to be cyclical rather than continuously expanding, if civilizations rise and fall over millions of years rather than spreading steadily across interstellar distances, then the galaxy might be filled with the archaeological remnants of countless civilizations that flourished and vanished long before we evolved to look for them. The tools for conducting this broader archaeological survey are already being developed. High-resolution orbital imaging, advanced pattern recognition algorithms, and robotic exploration missions could systematically examine the surfaces and atmospheres of other worlds for signs of artificial structures or objects. The same techniques we use to identify archaeological sites on Earth could be adapted to recognize the signatures of intelligence on alien worlds. As you imagine this expanded search unfolding across the solar system, picture robotic archaeologists exploring ancient ruins on Mars, floating research stations, analyzing the chemical signatures of Venus's upper atmosphere, and deep-sea submarines probing the hidden oceans of Europa for traces of civilizations that might have thrived in the darkness beneath the ice. The possibility that evidence of ancient intelligence might be scattered across multiple worlds in our solar system opens up vistas of discovery that could transform our understanding of our place in the cosmic story. We might discover that Earth is not the sole cradle of intelligence, but one note in a vast symphony of consciousness that has been playing across the solar system for billions of years. This recognition would fundamentally change how we see ourselves and our relationship to the cosmos. Instead of lonely pioneers venturing into an empty universe, we might be the latest in a long succession of intelligent beings who have gazed up at the same stars and wondered about their place in the infinite mystery of existence. As our journey through deep time and hidden possibilities draws to its gentle close, we find ourselves standing at the edge of a profound realization. The story of intelligence on Earth, and perhaps throughout our solar system, might be far grander, far more ancient, and far more mysterious than we ever dared imagine. Picture yourself for a moment as a traveler through time, drifting backward through the millennia like a leaf carried by a cosmic river. You pass through recorded history, through the rise and fall of empires, through the development of agriculture and the first cities. But you don't stop there. You continue backward through the ice ages, through hundreds of thousands of years when our own species was young, through millions of years when the continents had different shapes and the oceans covered different lands. In this vast perspective, our entire recorded history becomes just the most recent page in an immense book. The civilizations we know, Egypt, Mesopotamia, Greece, Rome, appear as recent experiments in human organization, built perhaps on the accumulated wisdom of countless previous attempts at complex society that have been lost to time. This possibility is not diminished by the absence of obvious evidence, but rather illuminated by our growing understanding of how thoroughly Earth erases its own history. Every mechanism we've explored, the recycling of oceanic crust, the patient work of erosion, the catastrophic resets of asteroid impacts, and supervolcanic eruptions, the burial of coastlines beneath rising seas, reminds us that absence of evidence is not evidence of absence when dealing with such vast stretches of time. What would it mean for our understanding of human nature if civilizations had risen and fallen many times before our own? Perhaps the recurring themes we see across cultures, the flood myths, the legends of golden ages, the stories of advanced beings who once walked among humans, are not mere fantasy, but distant cultural memories of real events preserved through oral tradition across tens of thousands of years. The megalithic structures that puzzle us today, Göbekli Tepe, Stonehenge, the precision-fitted stones of South America, might represent not the first flowering of human architectural ability, but the recovery of techniques that were once commonplace. Perhaps these monuments are attempts to recreate the achievements of earlier civilizations, built by people who retained fragments of ancient knowledge, but no longer fully understood the principles behind it. In this view, human technological development becomes not a simple progression from primitive to advanced, but a cycle of loss and rediscovery, of knowledge gained, forgotten, and slowly reclaimed. Each civilization would be both inheritor and ancestor, carrying forward whatever wisdom survived the last catastrophe while laying the groundwork for whatever comes next. The implications extend beyond human history to touch the very nature of consciousness itself. If intelligence is indeed cyclical, if it arises naturally from the evolution of complex systems given sufficient time and suitable conditions, then consciousness becomes not an accident, but an inevitability, a fundamental property of the universe as basic as the formation of stars or the evolution of galaxies. This perspective offers a kind of cosmic comfort. In a universe where individual civilizations rise and fall like waves on an ocean, consciousness itself becomes the constant, the eternal observer that witnesses each flowering of intelligence, each moment of wonder, as minds discover their place in the cosmic order. Perhaps this is why we feel such a deep resonance when we stand among ancient ruins or gaze up at the night sky. Some part of us remembers, not through genetic inheritance, but through the deeper connection that links all conscious beings across time. We are not the first minds to contemplate infinity, and we will not be the last. The chemical signatures we leave in Earth's geological record, our plastic horizons, our metal concentrations, our isotopic markers, will join whatever traces previous civilizations may have left in the planet's deep memory. Future archaeologists, whether human or something else entirely, might find our industrial ghosts alongside evidence of minds that pondered the same questions we ponder today, millions of years before we existed. This cyclical view of intelligence offers a different relationship with our own mortality, both individual and civilizational. Rather than seeing death as an ending, we might view it as a transition, a return to the cosmic background from which new forms of consciousness continuously emerge. Our thoughts, our discoveries, our moments of wonder become part of the vast stream of awareness that flows through deep time, connecting all minds across the eons. Consider the profound loneliness that has characterized human consciousness throughout recorded history. The sense that we might be alone in a vast, indifferent universe. But if consciousness is cyclical, if intelligence has flowered countless times on Earth, and perhaps throughout our solar system, then we are never truly alone. We are part of an ancient conversation that has been unfolding for millions or billions of years, each generation of minds adding their voice to a cosmic dialogue that transcends any individual civilization. The stones of Göbekli Tepe, the precision of ancient megalithic construction, the mysterious ruins scattered across continents and hidden beneath seas, all of these might be messages in this long conversation, attempts by previous minds to communicate across the vast gulfs of time. They built in stone because they knew stone endures. They encoded astronomical knowledge because they understood that the patterns of stars and seasons would remain constant even as civilizations rose and fell. In our own era, we face the same challenge that may have confronted countless civilizations before us: how to preserve knowledge and wisdom for minds that will come after us, possibly long after our own culture has been forgotten. Our digital storage systems are fragile, dependent on technologies that require constant maintenance. Our books and documents decay within centuries. Only our nuclear waste and chemical signatures in the geological record seem likely to survive the kind of time spans we're contemplating. Perhaps the most profound message we could leave for future civilizations is not technological information, which would likely be obsolete by the time they discovered it, but philosophical and spiritual insights, the understanding that consciousness is precious, that intelligence is part of the universe's way of knowing itself, that the capacity for wonder and love and creativity transcends any particular form it takes. This is why the search for ancient civilizations ultimately returns us to questions about our own purpose and meaning. If we are indeed part of a long cycle of consciousness, if intelligence has arisen again and again throughout Earth's history, then our role becomes clearer. We are the universe's way of remembering itself, of preserving and passing forward whatever wisdom each generation of minds manages to discover. The deep time perspective that emerges from contemplating ancient civilizations offers a peculiar kind of peace. Our individual anxieties, our cultural conflicts, our technological challenges all take on different proportions when viewed against the vast backdrop of geological time. We are temporary arrangements of matter and energy that have somehow achieved the miracle of self-awareness, participants in a cosmic process that is far larger and more enduring than any of us can fully comprehend. As you drift toward sleep, imagine yourself floating gently through this vast river of time, your consciousness briefly illuminated like a candle flame in the cosmic darkness, but connected through some invisible thread to all the other flames that have flickered before you, and all those that will kindle after you are gone. You are not alone in the universe. You are part of something ancient and ongoing and ultimately mysterious. The whispers in stone, the chemical signatures in sediment layers, the drowned cities beneath rising seas, the possible artifacts scattered across other worlds. All of these are breadcrumbs in a trail that leads not to any final answer, but to an ever-deepening appreciation of the mystery of existence itself. We may never know with certainty whether previous civilizations rose and fell on Earth before our own, but the search for them has already transformed how we see ourselves and our place in the cosmic story. Perhaps that transformation is the real treasure hidden in Earth's deep memory. Not proof of ancient astronauts or lost technologies, but the recognition that consciousness is the most precious and mysterious phenomenon in the known universe, and that we are privileged to participate in its unfolding, however briefly, in this moment of cosmic history. Sleep well, knowing that you are part of an ancient dream that encompasses not just human awareness, but the universe's long, slow awakening to its own extraordinary nature. The story of intelligence on Earth continues through you, as it has continued through countless minds before you, and as it will continue through minds we cannot yet imagine, writing new chapters in the endless book of cosmic consciousness. One thought, one dream, one moment of wonder at a time. Thank you for joining us on this journey through deep time and hidden possibilities. If these cosmic mysteries have stirred your imagination, gently consider subscribing to continue exploring the vast questions that connect us all to the infinite story of existence itself.